Okay, so I wanted to go through the fractions, decimals, and percentages unit test just to make sure that if you're having a hard time on this test, you're not sure how to get a good grade. If I model these problems, hopefully you can then attempt them yourselves. It'll give you different questions, but at least it'll give you a sense of how to do each of the types of problems that you're going to encounter. And then you can retry it and try to improve your grade, okay? So once again, this is for fractions, decimals, and percentages unit test, okay? It says it'll be about 18 minutes. I really have no idea how long this will take. We'll find out. It says Bo is buying a board game that usually costs B dollars. The game is on sale, and the price has been reduced by 18%. Which of the following expressions could represent how much Bo pays for the game? So a couple things. We're basically asking how much he pays for the game, which is the sale price, right? So if you think about it, right, let's just say let's y equal the sale price, right? And let x equal the original price, whatever that original price is. So it says Bo is buying the board game that usually costs B dollars. Okay, so I'm going to write that as, instead of let X equal that, they said it was B. So let's let B equal that. All right, so let B equal the number of dollars the game originally cost. The game is on sale, and the price has been reduced by 18%. So the sale price, call it Y, you can pick any letter you want, is equal to the original price, right, minus the discount, which is 18% of the original price. So what portion of the original price are you still going to pay? Well, this is 100% of the original minus 18% of the original, which is equal to what? 82% of the original, right? So we know that that's the same as 82B. So we're looking for a sale price that's 82% of the original price. So obviously 0.82B works, all right? What other value might work? Well, B minus 0.18 is great, except for it doesn't have the B that you need to have there, right? It's not minus 18 cents, right? It's minus 18% of B. So you've got to make sure you have that B. So B minus 0.18B, that's going to work, and 0.82B, that's going to work. And this is why, right? It's 100% of B minus 18% of B is equal to 82% of B. That's the sale price. That's what you're going to pay. All right, the next one says the sales tax in your city is 4.4%, and the item costs $3 before tax. How much tax would you pay on that item? All right, so this is actually a really easy one because they're telling us the sales tax is 4.4%. So what's the tax rate? 4.4%. So literally, you're just saying what is 4.4% of 3? That's the question they're answering. What is 4.4% of 3? What is that tax worth? And there's lots of ways to do this problem. You can say y is equal to 0.044, which is 4.4%, right? 4.4 out of 100. So that's 4 hundredths and 4 thousandths, right? So we're looking at 4.4, percent. And then of means times, and then times 3. Okay, so you could just do it as a direct translation, right? So what is y is equal to 4.4% is what decimal value, 0.044, and of means multiply times by 3. You could also set up as a proportion, is over of equals percent over 100. So if you set it up that way, what you'd be looking at is the is missing. We know it's out of 3, so some value out of 3, if you will, is equal to 4.4%, and percents are always out of 100. So you could set it up this way as well. Either way you set it up, you're going to get the same answer. So on a calculator, I was going to do it over here. You can see you're going to get either 0.044 times 3. That's 0.044 times 3 is equal to 0.132, which is basically, it's just rounded to the nearest cent. So that'll be 13 cents. So 0.13. And the other way you could get that answer is that you could just take the proportion here and solve with the cross product. So that'd be 3 times 4.4, and then get that answer and then divide it by 100. So it's 0.132 once again, round to the nearest penny, 0.13. So either way, your answer is going to be 13 cents. Okay. The next one says express 3.81 as a mixed number. So I don't really know what math there is to do on this one. It's pretty easy, right? So let me show you guys what it looks like. So 3.81 is the same as 3 and 81 out of 100, right? So I guess that's what it means by express it as a mixed number. So this is 81 ending in the hundredths place, right? So this is 3 and 81 hundredths. You can't simplify 81 hundredths, so that's it. So you literally write 3 space 81 slash 100. That's it. This one says, enter the answer as an exact decimal or a simplified fraction. All right, so let's see what we get here. So this is going to be negative 0.2, and we're adding to that 7/10. Now, that's the same as negative 0.2 plus 0.7, and who's going to win positive by how much? 0.5. So the answer is going to be 0.5. Okay. This next one says, Joelle is working on a school report in a word processor. She wants to place an oversized image, which is 30.51 centimeters wide, so that it appears centered on the page. The width of the page is 21.59 centimeters. In the program, horizontal positions to the right of the leftmost edge of the page are positive. Okay, what horizontal position for the left edge of the image should Joelle use to center the image? So this is a very fancy one. Let's see what we can get into on this one. It says Joelle is working on a school report in a word processor. She wants to place an oversized image, which is 30.51 centimeters wide, so that it appears centered on the page. So the image is actually wider than the page. This is a really weird problem. I don't know why this problem is in it. That's fine. So 21.59 centimeters is the width of the page. Okay, so that's the length of the page. All right. She wants to center this 30.51 centimeter image. So there's some image that's 30.51 centimeters. Okay, so 30.51 centimeters. And that's the length of the image. This is the oversized image, right? And she wants to appear centered on the page, right? Okay, fair enough. So if she wants it to appear centered on the page, I don't know. Okay. So basically, what you're looking for here, I would assume, is you want the middle of 30.51, right, to be centered here, right? Sorry, I'm trying to work through this myself. It's a little bit of a weird question because I don't know when you'd be using an oversized image on a page that's too small to mount it. But let me think about this for a second. So if I'm interpreting this problem correctly, this is a very unusual question. So what I'm saying here is, you have this oversized image. You got this paper, this page. It says that everything measured from the leftmost of the page is positive, which basically means that this left page is 0, and you're moving it to the positive direction to the right. That means the negative direction to be the left, right? So if you put a negative value, it's going to offset the image, the oversized image, to the left of the page so that it appears to be centered on the page. So we know we're going to put a negative value in for the leftmost edge of the image. Okay, the question is where, right? Well, we know that the center of the image itself is 30.51 for the length of the image cut in half, which is 15.255 on the left and 15.255 on the right. We know if we take the page and cut it in half, which is 21.59 centimeters cut in half, which would be 10.795 on the left and 10.795 on the right. So what you're really looking for, as far as I can tell, is you're looking for this distance here, right? How far negative you have to go. Let me make this blue. How far negative do you have to go, right? In the negative direction, so that it appears this larger image is centered on the page when you mount it. So if we think about that, we know that we need it to have the appearance of being centered. So we really are looking at these two values here, right? And we know that on the left of the center, you've got this 10.795. But we need it to be on the left of the center, 15.255. So the additional amount of space is what we need to offset it by. So what you have here is you have the 15.255 minus the 10.795. And that's going to tell you how far to the left of 0 you have to go when you're mounting this picture. So what that would give you is, on a calculator, so let's do it. So 15.255, and you're subtracting from that 10.795, and you would get 4.46. So I'm getting here a reading at 4.46 to the left of 0. So that means if you're marking it right, you would have to start at negative 4.46. So if you start at negative 4.46 for the image, you'd basically have a distance of 15.255 to get to the center of the actual page, which would be the center of the image that you want. And then it would basically have this like buffer on the right-hand side of an additional 4.46, right? So this is kind of what I'm interpreting it as. So it says, what horizontal position of the left edge of the image should Joelle use to center her image? I would say if you put in negative 4.46, then it's going to be 4.46 overspill on the left and 4.46 overspilled on the right. So that's kind of what that problem is talking about. It's a weird problem, so if you got that one wrong, I wouldn't blame you. All right, let's do the next one. This is way easier. Look at the difficulties change in this unit test. It's hilarious, right? Okay, so this one's 13 tenths. Well, this is super hard. 13 tenths. How many times does 10 go into 13? 1 with 3 left over. So 1 and 3 tenths. 1.3. Awesome. I think you guys should know how to do that. So 1.3. Let's look at the next one. Order the following numbers from least to greatest. Okay, so when you're doing something from least to greatest, you just want to make sure that you're thinking of the values carefully. So you've got fractions and you've got decimals. I'd make them all fractions or all decimals. I think it's easier just to make them all fractions in this case. So what is 5/4 equivalent to? That's 1 1/4, which is 1.25. What is 1 8/25 equivalent to? That's the same as 1 times top and bottom by 4. You're looking at 8 times 4, which is 32. So you're looking at 1 32 hundredths, which is 1.32. Okay? And then you've got the last one, which is just 1.3, which is obviously 1.3. So you're really just putting this in order, 1.25, 1.32, and 1.3. Well, the smallest one's going to be 1.25. And 1.25 is going to be the 5/4. Okay? The next smallest one is the 1.32, which is actually the 1 8/25. So that's the next smallest one. And then the largest one, actually, no, my bad. This one's going to be there, my bad. So 1.3 is smaller than 1.32 because this is the same as 1.30. Boop. So when we're looking at this, right, it's going to be 5/4, then 1.3, then 1 8/25, because it goes from 1.25 to 1.3 to 1.32. And that's kind of how it goes. All right, next question. All right, let's do this one. This one says negative 54 50ths, and then you're taking away from that 40 hundredths, and you're going to add to that 1.65. Okay, it says enter the answer as an exact decimal or a simplified fraction. So I'm just going to write these as decimals. I think it's more accurate. So I would just double this top and bottom, and you get negative 104 hundredths. And then you have negative 40 hundredths. And then you're adding 1.65. So if we make them all into decimals, then negative 104 hundredths is the same as negative 1.04, right? Because 100 goes into 104 one time with 4 hundredths left over. And then negative 40 over 100 is the same as negative 0.4 because 4 tenths is the same as 40 over 100, right? Divide top bottom by 10. And then you've got this positive 1.65, okay? So remember, you can change subtraction to addition. So you can think of this as negative 1.04 plus the opposite of positive 0.4, which is negative 0.4, plus the 165 or 1.65. So now we've got this to work with. We can do a scoreboard if you'd like. So if we scoreboard this, you're going to put all your negatives together, all your positives together, and then compare. You've got 1.04 on the negative side. You've got another 0.4 on the negative side. So what's your total negative? Your total negative is going to be 1.44. Who's going to win, negative or positive? Positive. By how much? Take away the losing side. So you're just going to subtract 1.44 from 1.65. 5 take away 4 is 1, 6 take away 4 is 2, and 1 take away 1 is 0. So this is going to be 0.21 on the positive side. And that's kind of how you do it. What did I do wrong there? Did I do something wrong? It says not quite. What did I do wrong? Did I put something in wrong? Did I interpret something wrong? Let's investigate this one. It says negative 54 50ths, which is the same as negative 104 hundredths, which is the same as negative 1.04. Oh. Sorry, guys. I made a little boo-boo here, didn't I? Silly me. And everybody makes a boo-boo. I'm glad you guys saw me make one too. What did I do wrong? Right there. So when you double top and bottom, right, you've got to double the 54, not just add 50 to it, right? I added 50 to the bottom and the top. I should have doubled the top and bottom. It's so silly. Anyways, so what's 50 times 2? 100. What's 54 times 2? 108. So that should have been 108. So what we're really looking at here is negative 1.08. This is going to be negative 0.4, and then we have the plus 1.65. So what is your total negative now? Now your total negative is negative 1.48. And we're going to compare that to positive 1.65. Who's going to win? The positive by how much? And we get 1.65 minus the 1.48. And that's going to be our answer. And so 5 take away 8 can't do it. Borrow. 15 take away 8 is 7. 5 take away 4 is 1. So you're looking at actually not 0.21, but 0.17. So sorry, everybody, for my silliness. All right, so let's move on. Ellis's backyard. So it says here, Ellis's backyard has a 6.25 by 6.25 meter patio, which she would like to build a 1.5 meter wide extension around 3 sides of the patio, as the figure is shown. She will buy 0.25 by 0.25 tiles that come in 25 to a package. Okay. So basically, let's investigate this one here. So Alice's backyard has a 6.25 by 6.25 meter patio. Let me just copy this image. Easier for me to mess with it. All right, so here's the image. And let's just write in our numbers as we get given them. So it says 6.25 by 6.25 meter patio. So basically what she's saying is that this patio is 6.25 meters by 6.25 meters. Okay, so that's the distances for this patio. Okay, she would like to build a 1.5 meter wide extension around 3 sides of the patio. So what she's saying is that this distance here, okay, is 1.5 meters. So this distance is 1.5 meters, and this distance is 1.5 meters. And you can see that this distance here would also be, that distance would be 1.5 meters. And so this distance is also 1.5 meters. Okay, and that's what she's talking about. She will buy 0.25 by 0.25 meter tiles that come in 25 to a package. All right, how many packages does Ellis need to buy to build the extension? Okay, so basically, the only reason that they're giving you the 6.25 by 6.25 is, I guess, so you can either do the large space and then cut out the part you already have, or to give you the dimensions of this kind of blue sections that you're going to be adding. So I think the easiest way probably is to do the whole space and then cut out the part you already have, the white space. So in this case, what we're kind of doing here is we're just going to start by saying, what is 6.25 by 6.25? So 6.25 times 6.25 is the entire patio itself. So that's the area of the patio. And so the area of the patio is, so let's interpret that, 6.25 times 6.25. That's 39 point, oh, that's funny. Wouldn't have thought it'd be that. 39.0625. Did I punch that in correctly? 6.25. Okay, right. All right, so that is the number of square meters that we're talking about for the patio itself. The total size of the large patio, including the extension, all right, it's going to be, you're adding 3. So then the total distance here is going to be 9.25, right? And then on the other side over here, it's only going to be the 6.25 plus the 1.5. So you're looking at 7.75 meters. So if you think about this like full amount of the large rectangle, right, if you wanted to like highlight this whole thing, right, this big old thing, right, that whole thing is going to be equal to the area of 9.25 plus by 7.75, basically, right? That's that whole region there. So let me just kind of change this to a smaller highlighter, and then we can highlight maybe. So this whole entire region is basically those two elements, okay? Those length and width dimensions. So now when we go through and we do it, right, we can say that 9.25 by 7.75 is going to be the area of the entire region that we highlighted there, right? That's the area of that entire region. So let's do that on a calculator as well. So what you get here is you get 9.25 times 7.75, which is 71.6875. Okay, so 71.6875 square meters. All right. So the difference between these two is going to be the extension itself. So if you took that 71.6875 and you subtracted from it the 39.0625, you're going to get the extension, right? The new stuff that you need to build. And so 71.6875 minus 39.0625 is going to give you 32.625. So the area of the extension is going to be 32.625 square meters. That's the amount of the area of the extension that she needs, 32.625 square meters. All right. Now the actual tiles she's buying are 0.25 by 0.25. So if you think about it, right, each of those little tiles that she's going to be buying, right, it's 0.25 by 0.25, which is what amount of square meters? Let's look at that. So 0.25 by 0.25 is 0.0625 square meters. So this is 0.0625 square meters per, whatever you call it, tile. So this is the amount of area that each tile covers, 0.0625 square meters. This is the total area that you need to cover, right? It's the whole rectangle minus the patio that you don't need to build because you already have it. And so then that's going to give you the answer you need, because you got to figure out how many you're going to buy, right? So how many packages does Ellis need to buy to build the extension? Well, the first thing you got to figure out is, well, how many tiles does she need, right? So to figure out how many tiles she needs, you're going to take the total area you need, and you're going to divide it by the area each tile provides. So let's do that. So you're going to take that total area of 32.625, and we're going to divide that by 0.0625. And that's going to give you 522. So it means to fill this blue space, she needs 522 tiles. So we know that this person needs to buy 522 tiles, right? So that's the first thing we can zoom out and like write that down. So after all that work, what we figured out is that, what's her name? Ellis? Ellis needs 500, is it 522? Yeah, 522 tiles. So you got 522 tiles. All right. Now they come in packages of 25 each, right? So you take that 522 and divide it by 25, and that's going to give you the number of packages that you need to buy. So what's 522 divided by 25? 522 divided by 25 is 20.88. So she needs to buy 20.88 packages, but you're not going to be able to buy a package that's 0.88 packages. Sorry, they don't sell them in 0.88s. They sell them in whole packages. So it says, how many packages does Ellis need to buy to build the extension? Well, you can't just buy 20. It's not going to be enough. You can't buy exactly 20.88. So how many packages would you need to buy? I would say the best answer is you need to buy 21 packages because you need to have enough tiles to cover the 522 tiles that you're going to use to make this extension. Now, if you were in a real world situation, you want to buy extra as a cushion just in case some tiles broke or there were some construction issues that happened. But let's assume that they want just the smallest number of packages you could buy where you'd have enough tiles to complete the job. And that would be 21. So I would say 21. And that's the answer. All right. Hopefully that helped you guys.